So my name is Bob Denaro. I'm manager of the domestic engineering group here at Dragon Innovation, and I oversee the customer quality aspects of whatever customers need for their products. Reliability is the ability to meet the customer's needs in a known condition. So from the customer's point of view, something works, and it works every time they go to use it. The way you achieve that may be several different ways. You could overbuild something and build it extremely well, or you can put diagnostics in place to continuously monitor the health of a product. Quality is control. It's control in the manufacturing process to maintain the reliability levels that you've established. You've got tolerances with accept and reject criteria for producing product consistently and repeatedly so that the customer receives a good product. People do things with your products that you aren't expecting them to do. Customers often are anxious to get into the manufacturing process and start producing products so they can gain revenue. And they don't think about, what am I going to do with returns? How many returns am I going to get? So it's very important to think of ways people can break the product, because this in the end is going to cost you money when returns come back for whatever reason. So things like accelerated life testing, where you have voltage margining, drop testing, frequency margining, temperature cycling, anything to accelerate the life of the product and see how you can break it. You want to push the operational envelope of a product with respect to a variety of things. So for example, if something is designed to work from 0 to 50, does it stop working at -2 or -20? Conversely, does it stop working at 52 or 90? Pushing the envelopes of the design with respect to many things to determine where it's going to break helps you identify ways to control production to maintain those quality levels and reliability levels. But these are the kinds of things looking forward. You've identified all of the possible issues, and some of them you make the decision to change, and other of them are cost prohibitive, but at least you're armed with another tool. If you don't do this, you end up with additional scrap, or as we call it, a bone pile. Parts that can't be used in the process of building your product. If some of those actually make it through the process, we call those manufacturing escapes, and you end up with a customer who receives something that doesn't work or is less desirable than what you had anticipated delivering to the customer. So it's very important to make sure that these controls are put in place so that your quality levels are maintained and you're producing consistent, repeatable products. So you're wrapping up your prototype and you're in the final stages before manufacturing. I think this is the ideal time to do the accelerated life testing, because you have one last opportunity to make design changes before you go into mass production. Knowing what your customers are going to see for early life failures before they do is a large advantage. Having the opportunity to design out any of those early life failures before you launch into mass production is key in saving you a lot of money. Some of these cost to quality considerations are important when you're interviewing your contract manufacturer and making sure that they're going to be able to repeatedly produce your product to the specifications that you've given them. So you want to make sure that they have systems in place to manage and control process and components going into your thing. If for some reason you're having systemic failures, you want to make sure you have the ability to go back and find out, okay, where did these components come from? Typically there's date codes with components that are produced, and if it's a lot of bad components, you can capture that with the ability to trace which of your things were built with these date codes. You want to make sure that the controls are in place, and it's very important to think about things like accept and reject criteria for producing a product. Built-in self-test. Does this work before I put it into the next assembly? So all of those iterative things just increase your chances of having a top-notch quality product being delivered to the customer. So if you can segment a design into functional blocks, controls, graphical user interface, power, having the ability to test these individually before you put it together as a system is a huge advantage in manufacturing a complex product.